Hello children, this is your physics teacher Sharma and I welcome you all to today's class. In the previous class when we started discussing metals and non-metals, we have learnt the physical properties of metals and non-metals. We have discussed the properties such as ductility, malleability, conductivity and being sonorous. As a part of that, we have learned that metals are ductile, that means they can be drawn into wires. Metals are malleable, that means they can be beaten into sheets. Metals are having good conductivity, that means they can conduct electricity as well as heat energy. And metals are sonorous, that means they produce sound when they are struck hard with any material. Okay. At the same time, we have also learned that non-metals are not ductile, they are not malleable, they are not good conductors of heat and electricity, and they are not sonorous. However, there are also some exceptions. In spite of all metals being very hard materials, sodium is a metal which is very soft that can be cut with a knife. Mercury is a metal which is in its liquid state. Coming to non-metals, graphite, which is other form of carbon, is a good conductor of electricity. Okay, and we have also learned about bromine being a gas in its liquid state. Okay, now let us discuss about the chemical properties. In today's class, we will discuss about the reaction of metals when they are burnt in air and when they react with water. Okay. Now, when we say that any metal is burning in air, we should understand that it is actually combining with oxygen. Okay. When we say any metal is burnt in air or when it is reacting in the presence of air, we should understand that it is only combining with oxygen. So, in this class, we will be discussing about the reaction of copper, aluminium, sodium and potassium with oxygen. Okay. Now, when copper, it is burnt in air, it combines with oxygen to form copper oxide. Is this equation balanced? Definitely not. Okay. Two atoms of copper will combine with one molecule of oxygen, that means two atoms of oxygen to form two molecules of copper oxide. Copper, as you all know, it is reddish brown metal. It combines with oxygen and it gives you copper oxide, which is black in color. Okay. Now coming to aluminium. Aluminium, it combines with oxygen to form aluminium oxide. Okay. So two atoms of aluminium will combine with 3 atoms of oxygen. Is that balanced? No, not yet, because we are having 6 oxygens here. I write 2 here and I should be having 4 aluminiums. So 4 atoms of aluminium will combine with 6 atoms of oxygen to give me 2 molecules of aluminium oxide. Okay. Now coming to the next metal, sodium. Please remember, when we are writing the symbol of an element, no cursive handwriting and it should be block letters. Okay? You cannot join one alphabet with the other alphabet. So sodium, when it combines with oxygen, it gives us sodium oxide. Okay. it gives us sodium oxide. Is this balanced? No. Okay, we have 2 oxygens here, so I write 2 and there are 4 sodiums. Okay. Now coming to potassium. Potassium combines with oxygen. This also gives us potassium oxide. Okay, and this also we balance in the same way. I write 2K, 2 potassiums. There is only 1 oxygen here, but there are 2, so I should be writing 2 here. So it makes potassium 4. Okay. So what do we notice in all these 4 reactions? We notice that always when metals are reacting with oxygen, we are getting metallic oxide. Copper reacts with oxygen, we are getting copper oxide. Aluminium reacting with oxygen, we are getting aluminium oxide. Sodium reacts with oxygen, it is giving us sodium oxide. Potassium reacts with oxygen, it gives us potassium oxide. So whenever a metal is reacting with oxygen, that means whenever a metal is burnt in air and it is combining with oxygen, we are getting its metallic oxides. Okay, this is the first part. Now coming to the next part, that is reaction with water. Okay. See, I take metals like sodium. Sodium, when reacts with water, it immediately gives us sodium hydroxide and hydrogen gas. Okay, sodium, which is a metal and which is a reactive metal, when added to water, it very vigorously reacts with water to give sodium hydroxide, liberating hydrogen gas. Okay. Now if I take potassium, potassium also, when added to water, it gives potassium hydroxide along with hydrogen gas. Okay. Are these equations balanced? Checking that is your part. Okay. Now, similarly, if I take calcium, when it is added to water, okay, it gives me calcium hydroxide and hydrogen gas. So we see that whenever these metals, highly reactive metals, they are added to water, even cold water, they are giving us their metallic hydroxide, liberating hydrogen gas. Now if you have noticed, I have made a small separation when I have written there. Sodium, potassium and calcium I have underlined, but magnesium I did not underline. Okay, what could be the reason? I will tell you. These 3 metals, being highly reactive, they react with cold water, hot water and steam as well. Okay, it is not mandatory for the temperature to be high for the reaction to take place. Okay, now in case of magnesium, that would not happen. Magnesium will not react with cold water. It reacts only with hot water to form magnesium hydroxide and of course liberating hydrogen gas. Okay, now coming to the next 2 elements, aluminium and iron. Aluminium and iron also, they give their hydroxide and hydrogen gas, but not when they react with hot water or cold water. Okay, aluminium and iron will not react with cold water or hot water, they will react only with steam. Okay, so the reaction being same, the temperature required for the reaction to take place is differing. When Highly reactive metals like sodium, potassium and calcium, when these are reacting with water, whether irrespective of temperature, even if it is cold water, to give their respective hydroxides, all magnesium will react only with hot water. Now, aluminium and iron, they need steam. They need the water to be at a higher temperature for their reaction to take place. Okay, so that is about the reaction of metals when they are burnt in air and reaction of metals when they are treated with water. Okay, now that is all for today's class. And for today's homework, you make a list of different metals, their reactions with oxygen when burnt in air and reaction with water. Tabulate them so that it will be convenient for your further reference. See you in the next class again. Until then, have a nice time.